Hello, we're going to be demoing the Build AI-powered S3 security scanner project. So in this project, you're going to be building a scanner which scans S3 buckets for encryption vulnerabilities and gets AI-powered security insights in plain English. Cool. So this is a relatively easy project. Should take about an hour. Doesn't cost anything. The key concepts are AWS Lambda, Amazon EventBridge for scheduling, Google's Gemini AI, and Amazon S3. Awesome. So a 30-second summary. Data breaches from misconfigured cloud storages are one of the biggest risks in AWS. An S3 bucket without encryption exposes sensitive data to anyone with access. A public bucket misconfiguration leaks customer data information. According to industry reports, 60% of cloud breaches involve storage misconfigurations. Most teams react to security issues manually, get an alert, investigate, figure out what happened, but enterprises can't have humans checking bucket configurations every day. Companies like Netflix, Capital One, and Lyft build automated security systems detecting encryption issues and using AI to explain why configurations are risky, all running schedules without human intervention. You'll build the same professional-grade security monitoring, a serverless Lambda function that scans S3 bucket encryption, which sends findings to Gemini AI for analysis and shows you intelligent security insights. Then you'll schedule it to run automatically every 12 hours using the EventBridge. Awesome. How do these pieces fit together? In this project, you'll build a serverless security monitoring system using AWS Lambda, EventBridge, and Gemini AI. Instead of running servers 24/7, serverless functions only run when triggered. Which is, AWS Lambda is Amazon's serverless compute service. You write code, upload it, and Lambda runs it automatically when events happen. Supabase and a heap of other database providers have the same thing. AWS Lambda is just what it's called for this. And EventBridge is AWS Event Bus. It triggers Lambda on schedule, like every 12 hours or 5 minutes or whenever you want to set it up for. So maybe you can set it up for to be on a trigger. So EC2 instance started. Let's run a Lambda function for something. You'll use Lambda to scan S3 buckets with Gemini AI, then test it in the AWS console to see intelligent security insights. In the secret mission, you'll add the EventBridge scheduling so it runs every 12 hours without manual testing. Cool, so no serverless experience needed. This project guides you through everything step by step. You'll learn Lambda, EventBridge, and AI integration as you build. The only prerequisite is completing the AWS account setup project. So not sure if this project, the one we're on now, is for you. You can use the Ask feature here to query and figure that out. Super helpful. I definitely recommend using the Ask feature whenever you can here. So this is sort of what we will be building today. So you've got the EventBridge here, and that's going to be doing a daily 9 a.m. UTC trigger. That's the secret mission bit. We've got the S3 security scanner Lambda function, which sends results that are logged to CloudWatch logs. We've got scanning encryption config with the buckets, and then security findings go to Gemini AI. AI recommendations come back to the Lambda function, and then to the logs, and that's what we'll be able to see there. So super cool. So by the end of the project, you'll have a Lambda function that scans S3 buckets for encryption using the S3 API, an AI-powered security analysis with Gemini AI that explains encryption vulnerabilities in plain English, a verified AI output showing intelligent security insights directly in the AWS console, and in the secret mission, you'll be automating that process to scan every 12 hours with EventBridge. So there's no manual testing there. Cool, so I'm building an AI-powered security scanner. I'm doing this to help learn. This helps me. I'm building an AI-powered security scanner that scans my Amazon S3 buckets for security security vulnerabilities. I'm doing this to learn how to implement AI with AWS to help troubleshoot slash fix. We avoid AWS, so Amazon S3 bucket security concerns. This helps me avoid large, quote what is set up here, the 60% common, how did it say it? 60% of cloud breaches involving storage misconfigurations. Helps me avoid being a part of the 60% of cloud breaches that involve storage misconfigurations. Awesome. So there's a quiz here. We'll do ours at the end, but you can totally do it at the start if you feel confident. So we're going to be walking through the step-by-step guidance in this video, but there's definitely a low and a high level of guidance. So you can go down a little bit of guidance or not much at all, just explaining the outcomes that should happen. But yeah, we'll be going through and doing the step-by-step, but definitely check out these modes if you feel more confident in this topic, or you just want to do the project in sort of a harder setting. Cool. So as we mentioned, a prerequisite is completing the AWS account setup project. Before starting this one, you'll need an AWS account with IAM permissions to create Lambda functions and S3 resources. And if you're ever stuck with that or other things, you can join the Network community on Discord. Students like yourself are already asking questions about this project. So, yep, that's good. Definitely start with setting up this AWS account first. Cool, so we're going to first get a Gemini API token and write the scanner code. You're going to get the Gemini API key and write a Lambda function that scans S3 buckets for encryption issues. The scanner will output technical data like encryption, none, public access, false, raw findings that are hard to interpret. The AI will transform these into actionable security recommendations like critical, enables AES 256 encryption on bucket, X, to protect data at rest. So really turning those logs into something really tangible each time it runs through. You can set it at 12. We're going to do it 12 hours, but you can do it 5 minutes or however you want to set it up. Up to you. So in this step, we're going to get a Gemini API key from Google AI Studio, create the project folder in Cursor, and then write the AI-powered S3 scanner code. So I'm getting the Gemini API key and writing a Lambda scanner to using Python, and we're using Python for the scanner code, and getting the API key from, what's the link? Google AI Studio. This helps me interpret, you could say, the raw technical output from the Lambda function pre-AI digestion. What are we doing in this step? I'm getting a Gemini API key and writing a Lambda scanner using Python. Do a comment. Using Python for the scanner code and getting the API key from Google AI Studio. This helps me interpret the raw technical output from the Lambda function pre-AI digestion. That last bit sort of already said. Cool. So we're going to get your Google API key. Before you write any code, you need an API key from Google AI Studio. Your Lambda function, your Lambda function can use Gemini's AI to analyze security findings. So we'll go to this link. And we'll just move on to the screen. Just split the screen so this makes more sense. You can see what's going on. Cool. So we'll head there. I see a dashboard already. So I see this, but because I'm logged in. But if you don't, you see a Get Started button. There's also steps to follow through here to go and log in or create an account with Google. But because I see this, I'm just going to run with this. So I'm going to click Get API Key, and then Create API Key. So we'll call we'll call this key Amazon S3 security scanner, and then we'll have to create a project for this. We'll just call it Network Lambda S3 project. Doesn't really matter what you call it for this, but just so we can understand if we ever go create more keys that we're not going to go and use this one, or we don't delete something we're actually using. So we'll just give it a second. Cool. So we just create that project, and now we can create a key. Awesome. So we have our project and our key under that project. So we can go ahead and continue. So we can go over to here and we can open up the key and copy the key. This key will be deactivated by the time this project's out. So don't worry about me showing it off. Obviously, it's not a good idea to show off your API key. And then we'll paste it into here and press enter. This will follow us. All this will get saved throughout, and then we're going to use this key shortly when we go and configure something. Cool. Cool. So what is Gemini AI and why are you using it in this project? Gemini AI is Google's LLM. I'm using it to summarize and translate the technical raw output of the scanner script we are building into natural language I can read and act on quickly. The API key authenticates this, Gemini's, our access. Our is really the Lambda function's access to the Gemini AI. Cool. So what is Gemini AI and why are you using it? Gemini AI is Google's LLM, large language model. I'm using it to summarize and translate the technical raw output of the scanner script we are building into natural language I can read and act on quickly. The API key authenticates our access to the Gemini AI. Cool. Okay, so we're going to hop into Cursor now. So I will split screen with that. Cool. So we'll open Cursor. We'll click Open Project. Head to our desktop, wherever you want to save the stuff we're working on at the moment. I'm going to create a new file, or new folder, sorry. We'll call it AWS Monitor Gemini. Cool. And then we will select it and click Open. So out a little bit. Cool. Okay. So in Cursor, we're going to create a new file called s3scanner.py. It's going to be the, no surprises, the S3 scanner that runs on, well, in the Lambda function. But how we set this up, and this is very common, is you'll design, well, create a Lambda function outside of AWS, or if you're, in the case of if you're doing a serverless function on Supabase or any other, pretty much any other platform, do it outside of the console and then import it in some way. And this project, we're going to be just zipping it and then putting it up through there, uploading it through there. But yeah, you can do a bunch of different ways as well. You can set something up on an S3 bucket to transfer it as well. But we'll just do the zip. Cool. Okay, so we'll create a new file, call it S3 scanner. We're going to build two parts of this Lambda function. First scanning the S3 buckets, then adding encryption analysis. This way you can understand how each piece works before moving on to combining them together. So part one is scanning S3 buckets. Let's start by adding code that connects to Amazon S3 and lists all of your buckets. So I'll put this in here. Save. And you can see here there's a few, this probably looks a little concerning, like why is this underlined? This is fine because we're not working in this environment. If we wanted to run this locally, we need to do pip install generative AI or google.generative.ai, but we're not. We're running this on AWS in a Lambda function, and we're going to set up the requirements.txt file, which sets up what's going to be installed, effectively what's going to be pip installed when it gets ran. So that's all good. Don't worry about that. So we can run over what part one does. I'll just zoom out a little bit, or make this a bigger. So we're importing 4 things here. Boto3, which is how we're going to interact with AWS. JSON, that's a file format. OS, that's for interacting with files locally. And this won't be locally because we're interacting with, once this is on Lambda or on AWS Lambda, this is going to be interacting with like their local files, which is logs. Importing google.generative.ai as Gen AI. This is going to allow us to use our API key shortly. So Lambda handler is our main function here. We're initializing the S3 client. We're going to print a basic, just to let us know effectively what we're doing. We're scanning for encryption. We're going to get the response as pulling the buckets. We're writing the variable as a response. We're going to print the number of buckets we're going to scan. We're going to open an array of scan results, and then we're going to loop through all the buckets here. So we're going to add now the encryption logic in the next step. But this isn't complete, but this is just, it's important to understand exactly what's going on bit by bit, because if we look at it all at once, it can be quite daunting. So yeah, that's what this block of code does. We can see here a little bit more detail on these things. Cool. And you would have heard me say array instead of list. A list is an array. So yeah, this creates an empty array or list to store encryption check results. Yeah, I think that's clear. Cool, so now we're going to add part 2, which is the encryption check and AI analysis. This is where we're going to use more stuff from Boto3 and then some stuff from, I think you'll notice Gen AI isn't used here. There's like no, yeah, we haven't got there in part 1 yet, even though it's in the imports. So yeah, we're going to use that to actually do the analysis for us. So we'll notice this line here, we're going to replace that with what we're pasting in now, and just be really cautious to check your indentation. Python is a language that cares a lot about, relative to other languages, a lot about indentation. So if you're familiar with writing like in C, for instance, and you haven't written Python before, yeah, that's something to watch out for sure. Okay, cool. We'll go through and explain what this does in a second. But for now, I'll just paste that in there. Seem to have worked okay. Okay. What line are we on? 26. Okay. So we start off the encryption with you start off with part 2 of this code with an encryption try and accept. So a try and accept block is you're trying something, and if that goes well, then you just stay there and you follow through with that. And if it doesn't, then you go to the accept. Sort of a little bit like an if and else, if you're familiar with that logic. And you've got encryption, S3 client, get bucket encryption, bucket name. You're going to say this is true in this case. This is looping over all buckets. And we've got an encryption type. Just scroll along here. So we're tagging encryption with a few things here. And then in the accept, we're saying it's not encrypted, and the encryption type is none. So you could almost read this verbally as like, is it encrypted? If so, how is it encrypted? And we specify in that variable how it's encrypted. And then if it's not found, then you're going to go and just write it as not encrypted, and the encryption type is none. So we're storing that result. We're appending to the this array here, this list, whatever you want to call it, this information about how it was encrypted, also the name, whether it is encrypted, so it's a sort of a boolean there, and you've got the encryption type, so that could be a number of things, and you've got an if check there, if else, and you're going to print the status of the bucket. So is it encrypted? The name of the bucket. So it could be could be anything, whatever you call it, and then the encryption type. So then we're going to tag for encrypted buckets, and then here comes I should re-explain this. So lengths are for R in scan results, if not are encrypted. So you're indexing on R to encrypted, and then scroll across. And then you're counting unencrypted buckets. You're tagging unencrypted buckets. I can expand on that a little bit more, exactly what this is doing around counting unencrypted buckets. But yeah, it's just finding the ones without an encrypted tag on them. Cool. So use AI to analyze security findings. I'm going to print just this little tag to start off. We're going to configure Gemini. So we're going to get our API key from our environment. This wouldn't work right now because we don't have an environment variables file, a .env file. But that's not a concern. We're running this on Lambda after all, so that's all good. And then you've just got a basic, you can think of this as sort of an error catch more than anything, just a quality of life thing. If we don't have an API key, it's going to, rather than just blow up, it's going to tell us that we don't. Else, it's going to set that and use whatever model we pass it here. Cool. So this is the prompt here. You are a AWS security expert. Analyze this S3 encryption scan and provide a brief security assessment. And here's some more information, like going into the prompt that we can use. Also indent this, I guess. We're going to another try, another accept. We get the response from the model, and then we're going to form that response into text, and we're going to use that here to print it out as part of the log. We'll see this in CloudWatch. And that's building the final result, the output. And then we've got the printing, so it's going to be like 0 out of however many buckets, say 4 or 5, need encryption. So that ideally you'd want 0, you might see 1 or 2, and then you're going to see a return there. Cool. I'll quickly touch on what this says here. Encryption checking. The section loops over the S3 buckets and checks if each one has encryption enabled. It builds a list of findings that will analyze with AI. So the list is that array I spoke about at the start. And the AI analysis, the section takes the raw scan results and sends them to the Gemini AI. The AI transforms technical findings into plain English security recommendations that explain the impact and urgency. Cool. Yeah, if anything I said here didn't make any sense, this is an explanation of the lines there. Or you're very welcome to use the Ask chat here to ask if you have any questions about something. Cool, so we'll just add a screenshot of this. Should save this file. Cool, and then you can now copy files right into here, which is really useful. My scanner code uses Gemini AI, the AI analysis part. We can say Gemini AI to scan and convert technical language to plain English. Plain text. Or maybe natural language. Better way to put it. Into natural language. The AI analysis part uses Gemini AI, the exact model I think specified here. You can really play around with exactly what model you want to use. There's a bunch listed on Gemini or Google's site. This is another valid one, 2.5 Flash, slightly newer. Really doesn't matter that much. These aren't particularly complex calls. This code will scan S3 buckets and report back in natural language its findings. Cool. So deploy to AWS Lambda. Now that you've written your AI-powered S3 scanner code, it's time to deploy it to AWS Lambda. You'll package your code with dependencies, create IAM permissions, deploy the Lambda function, and test it. Cool. So what's the architecture we're deploying? Your security scanner has three main components: Lambda, which runs your Python code; S3 API, which provides bucket encryption data; and IAM, which is for permission management. You'll package your code into a zip file, upload it to Lambda, and attach an IAM role that grants Lambda permissions to read S3 bucket configurations. Lambda runs in a serverless environment, so you don't need to manage servers. You just upload your code to AWS and it executes it when needed. So super useful. In this step, you're going to package the Lambda function with dependencies, deploy the Lambda function to AWS, and test the AI-powered AI-powered S3 scanner code. Cool. So I'm packaging my code with dependencies to allow me to allow the Lambda function environment to successfully execute the code I am putting together, or the scanner S3 scanner Python code I have put together. Cool. So we're going to package Lambda for deployment. Lambda needs dependencies bundled in a zip file. In Cursor, create a new file called requirements.txt. This will be where we put, should check that spelling's correct. I think it is. Cool. This is where we're going to put so effectively what we had up here, which is Boto 3 and this Gemini part. But I'll read out what does requirements.txt mean. Why do we create this? Requirements.txt is a Python convention that lists all external libraries your project needs. When you deploy to Lambda, this file tells AWS which packages to install. These are two libraries that your Lambda function needs: Boto 3, the AWS Python SDK, software development kit for accessing S3, and Google Generative AI for calling Gemini AI. You don't install them locally because Lambda will install them from the file when you deploy. So you're going to right-click the File Explorer, create a new one, new file, and we're going to drop Boto 3 and Google Generative AI so AWS knows what's up. Cool. So why do we need package dependencies? Lambda runs in a sandboxed environment without pre-installed Python packages. When you deploy a Lambda function, you need to include all the libraries your code imports. So the requirements.txt lists all the dependencies, Boto 3 and Google Generative AI. Pip installs them to a local folder, then the zip. Then you zip everything together so Lambda has access to both your code and its dependencies so it can run. So we can install to a package folder. Open a terminal and cursor. There's two different ways of doing this. I'm just going to close that for now. You can either use the shortcut, which is Control-Shift-, or you can go into terminal to the ellipses, terminal, new terminal. This will work fine. Should automatically open to the right spot, which it has. So we're going to set up a Python virtual environment. And that's like just what it sounds like. So you've got little like boxes or enclosures where certain things, so you install a bunch of, like, say 10 packages here, and they don't get installed globally, so they won't interfere with other packages. Like if you had an old version of matplotlib, you wanted to use an old feature, for instance, and it's just a random Python package, and you wanted also a new one in a different project, it wouldn't cause an issue where you've got two installed, which would usually cause an issue if you did it globally, but in a virtual environment, that's not a problem. So a virtual environment is like a separate workspace for your Python project. It keeps all your project packages isolated from other projects so they don't interfere with one another. Think of it as a sandbox where you can install whatever you need without affecting your computer's main Python setup. So we're going to run this, this command to create the venv file. You'll see it come up there. It does take about another 10-15 seconds before we can actually go and activate it. There's a bit of stuff which needs to get created, but it shouldn't take too long. And shortly, when we zip everything up, it will be this whole virtual environment will be put into the zip. So we've ran that command. It's slightly different for Mac and Windows. We see a little venv tag there. Cool. We're good to go. So we can also check if we have pip installed, which is a Python package manager. Oops. I can just type it by hand. Pip -- version. Cool. We're all good. Makes plenty of sense. So I see a version number. Go down there. If you have a problem, you can go down here, install stuff. Install Python and pip. But I imagine most people have Python. If you don't, that's totally fine. You can go down here and install it. I'm on Windows, so I'm going to click this one. And yeah, so this is the section where we're installing all of the stuff based on requirements, similar to what AWS will be doing shortly when we give them the zip file. This will take a little bit of time. The Google Generative AI package is large. It's not huge, but it'll take probably, I imagine, a minute or less to go install. So if you notice here, a little bit hidden, but this content here is, I think that's it. I think this as well, this extra flag, or those two extra flags, are for, we need them because that Lambda isn't running on Windows, it's running on Linux. And those flags are set up for pip installs to work broadly, such that we can run this on Lambda. If you run it without, it could run fine locally, but well, maybe on certain Linux builds as well, but on the stuff that's running on the AWS runs on, it won't be able to run. So that's what those extra flags are for. So Lambda runs on Linux. The platform flag tells pip to download Linux compatible packages and versions instead of Windows binaries. Without this, your Lambda will fail with import errors. So you should see pip downloading and installing both packages with Linux compatible binaries. Another reason why this takes a bit of time. And then shortly we'll zip this as well, which also takes a little bit of time. so that's finished installing that into the virtual environment. I'll just paste these commands in here. So it's going to create a, it's going to use the package and then zip it up. It doesn't create a package. It uses the package folder we just created on the previous command, and then it's going to go zip that. It does take a little bit of time. This can be up to 2 or 3, maybe even 5, depending on hard drive speed to zip this folder, but that's totally normal. And once we've seen that now, but once this loading bar is finished, we'll be good to go. But you should see a S3 scanner zip file, and there we can complete this validation while we wait for that. So how did you package your Lambda function with dependencies? I packaged my code by creating first a env virtual environment file, folder file, then a package folder, and installing the dependencies using pip into, or using the requirements folder with pip, using pip2, and installing the dependencies using pip alongside the requirements folder the requirements.txt file lists all of the Python packages our code needs to function. The zip file contains not just the Python, I think it might have ran twice. So there's this. Okay, we'll have to run that again. I might have clicked X. The zip file contains not just the Python code, but the necessary packages required to run it in or on AWS Lambda, notably Linux binaries. Cool. Very good. While we wait for this, we can just keep going down this list. It's my mistake for accidentally cancelling that zip. I thought I'd pasted it in twice. But we can just keep moving on and just let that run in the background. Cool. So I'll just sign into my AWS account. Here, and then I'll move that over in a second. Cool. So I just signed in there. Cool, and we'll just keep an eye on this installation process, the zipping process. We're going to create S3 encryption read policy. So your Lambda function needs permission to read S3 bucket encryption configurations. Let's create a policy that grants exactly those permissions. So we're going to log into our AWS console, if you haven't already. In the top search bar, let's type IAM. So what is IAM? What are policies? IAM, identity and access management, controls who can do what in AWS. And policies are JSON documents that define specific permissions, like can read S3 buckets or can write CloudWatch logs. You'll write a policy that grants Lambda exactly the S3 permissions it needs. So hover over IAM, and then we'll select policies. Cool, so we see a bunch of existing policies Amazon's created for us. Just check how this is going along. We'll click Create Policy, top right. We'll select JSON, and then we will paste this in. Zoom out a little bit so we can see. Cool. So what does this policy do? S3 list all my buckets, retrieves a list of all S3 buckets in your account. S3 get encryption configuration, reads the encryption configuration for each bucket. Resource star, Lambda can read encryption settings for all buckets, so that's what the star means. Same as if you see it in SQL, structured query language, a star is just all. IAM policies use JSON format, so effect allow grants access, and action lists the specific API Lambda can make. So you might see, if you've pasted it in with a white space at the top, you might see something that says leading spaces. This happens if you accidentally copied extra spaces before or after the JSON. Delete everything in the editor and then carefully paste only the JSON, starting with the first curly bracket ending with the last. Make sure there are no spaces. So for instance, if there was something like this, it might give me a trouble. I don't know, might not. There you go, leading spaces. So if we get rid of that, and then we click next, it'll be just fine. So that can issue that can pop up, but don't worry too much about it. Easy to fix. Cool. So we'll call the policy S3 encryption read policy. We won't give it a description. Not super important. So we'll click create policy there. Cool. So we've created it successfully. We can see that up there. Little thing come down. Little toast pop up. This is going almost there. Cool, so now we're going to create an IAM role for Lambda. So now you'll create the IAM role that Lambda will assume when it runs. This role will have S3 encryption, the S3 encryption read policy you just created, plus CloudWatch logging permissions. So if we go to IAM, search that again, and then we click on roles this time. We again get a bunch of roles that are predefined. We'll click create role. What is a role? Why do we need one? A role is a set of permissions that AWS services can assume. Lambda needs a role to access other AWS services on your behalf. Instead of giving Lambda permanent credentials, you create a role with specific permissions that Lambda temporarily assumes when it runs. Now you'll configure who can use this role. So select custom trust policy, and we're going to again use some JSON here to do the settings change for us. You can again run into the same issue with a leading space, so just be really careful of that. So we'll delete the existing policy that was there and just paste that one in over top of it. Cool. We'll click next. Now you'll attach the permissions to this role. So you need two permissions, your custom S3 encryption policy we just made, as well as the AWS's logging policy, so we can use or interact with CloudWatch using this. So what is AWS's logging policy? AWS's logging policy, is AWS Lambda basic execution role, allows Lambda to write logs to CloudWatch effectively. So you can debug your function. Without this, it won't be able to see execution logs or errors, which is definitely not what we want. Cool, so we'll search for the thing we just made and then select it. Cool, and then we'll search for the predefined function here, and we'll also add that. And click next now. Cool, so we'll call, we'll give that the role name of that, and we can just verify that both of these are selected, and they are, so we are good to go. cursor is doing. Okay, I think we're good. We've got our zip there now, so we can come back to that in a minute. Cool. You can see the role Lambda S3 scanner role has been created, so that's good. So now we can, our IAM role is now ready for Lambda. So you can now scan S3 buckets, bucket encryption, and write logs to CloudWatch using it. Awesome. So we can click View Role on the top right, the success banner, see more details if we want to. And then I'll take a screenshot of this. And just drag that over here. What IAM permission role did you create, and what permissions does it have? So the role I created was called the permissions I attached were Lambda. We can actually have a look. I think it's in here. Lambda basic exec, just shorten it to that, execution, and S3 encryption. Oops. These permissions allow Lambda to execute and monitor S3 bucket, as well as writing to CloudWatch, which is the logging platform in AWS. Cool. Step 3. Deploy and test Lambda. Now that your code is packaged and permissions are configured, you'll deploy the Lambda function to AWS, configure it with your Gemini API key, and test the AI-powered security scanner. In this step, you're going to deploy the Lambda function to AWS, configure the handler to use s3scanner.py, or your s3scanner.py file, and your Gemini API key as an environment variable instead of AWS, and then we're going to test that function to see how the security AI security analysis works. What are we doing in this step? I'm deploying my Lambda function and configuring both the S3 scanner.py file and the Gemini API key inside of AWS, so the Lambda function can use it. Cool. So now you'll create the Lambda function and configure it using your IAM role. In the AWS console, try searching Lambda. Cool, so we'll click on to Lambda there. To load, create a function, and then we will click on, or stay selected on author from scratch. We will give it the name S3 security scanner. We'll select the runtime of Python 3.12, and we'll leave the architecture as is. What is a runtime? A runtime is the execution environment for your code. It determines the programming language that version of Lambda uses to run your function. So we wrote it in Python. You can use Python here. Now you need to attach your IAM role you created. Expand the change default execution role by clicking the arrow. It's just here. What is a default execution role? The default execution role is a basic IAM role that allows, or that AWS creates automatically you're changing it to use your custom role with S3 permissions instead. Cool, so we'll click use existing role. We'll search for S3. You can see our Lambda S3 scanner role there. That's great. And we can see, scroll down, click create function there. Cool, so we see our Lambda function here. That's all good and well. There's still a little bit of stuff to run before we can actually run this. So we're going to configure the Lambda timeout. Before uploading any code, let's increase the timeout so your scanner has enough time to check all the buckets. It's currently set to 3 seconds. That might not be enough time, so we will go and update that. So we'll go into the configuration tab here, and then we'll go into general configuration. Should already be on that. We can see 3 seconds there is what it's set to right now. Very dependent on how many buckets you have, but we're going to just do 30 seconds. You can do less. You can get away with doing 3 seconds if you only have 1 or 2 buckets, but chances are, well, it's definitely possible you have 10 or 15, and then therefore that would cause an error just because there's not enough time for AWS to actually scan through using your Lambda function, or your Lambda function to run on AWS. So we'll click save. Now we're going to upload our code. So we will go to code here, and then we'll click upload from zip file. We'll click upload here, and we'll go on our desktop, and we can go to the AWS Gemini file or folder we created, and then we'll upload the zip. So not the, even though it's pretty tempting to just upload the Python file, we'll upload the zip here. Click open, and then we can click save. This can take a little bit of time because it's quite a big zip file, but that's all good. And you can see here there is a 50 megabytes limit. It really isn't a limit. You can see it just worked then. But if you do see an issue, this happens if your zip file happens to exceed a dynamic limit, which isn't actually 50 megabytes. If you're on Mac and you follow the standard pip install, you'll likely hit the Mac the CYGRPC error. Jump to a tab further down for cannot import if that is an issue. It has instructions to rebuild the Linux compatible binaries that produce a smaller 26 megabyte zip file, but that really shouldn't be an issue. So now we're going to configure the Lambda handler. Lambda needs to know which file and function to run by default. It looks for a lambda function.py, but your function is called s3scanner.py, so let's update the handler configuration. So we're going to go onto the code tab here, where we already are. We're going to click down to the runtime settings. That's below here. We're going to click edit, and we're just going to rename this to s3scanner.lambda handler there. Cool. Click save. So now the last thing before we actually run this, we configure the Gemini API key. Your Lambda function needs the Gemini API key to run the AI analysis. Let's add it to as an environment variable. On the S3 scanner Lambda function page, click the configuration tab, and then we'll go down to environment variables here. We'll see, click edit in the top right. Click add environment variable. So we've got Gemini API key there, and then I will go and get it from my clipboard here. It's not my clipboard, I'll just go back to the this, grab it from here, and click save. So you should now see an environment variable configured successfully. You see that up there. What are environment variables and why use them? Environment variables store configuration values like API keys, database passwords, and service endpoints. They're stored separately from your code, which keeps secrets secure. When Lambda runs your scope, it loads these variables into memory so your code can access them via os-environment.get, like I spoke on at the start when we were writing the Python code. This way, you never hardcode sensitive values in your code, and you can easily change configurations without redeploying your function. Environment variables are a security best practice across all cloud platforms and really throughout all of software development. So how did you configure your Lambda handler and API key? I configured the handler by updating the, I think it's called, the runtime settings. The runtime settings in AWS. Environment variables work by abstracting away, say, sensitive data like API keys, database passwords, etc., to a separate location. The handler tells Lambda to run the what do we call it? We called it S3 scanner. S3 scanner .py file. Not because its default is Lambda function .py. It will be Lambda underscore function. Maybe not. Anyway, cool. Very good. Now we're going to test the Lambda function here. So now let's test your Lambda function to verify it scans S3 buckets. On the S3 security scanner Lambda function page, switch to the test tab at the top. You'll see the test event configuration area. It's already got some default stuff in here which isn't relevant to us. We're just trying to run this once. So we'll chuck that in there. Also format JSON, it's already formatted, but if there was a white space, we would get rid of it. So an extra, a leading space or a lagging space. And then we can click test up here. This should take a little bit of time. That's completely normal. It's getting the response from Gemini, so it's all good. Cool. So we get a successful log there. That means it's responded correctly. And we can see there's a lot of information here, but the most important bit to verify that we've done our job correctly, we've set up the Lambda function to work with Gemini. As we can see, this is 0 out of 4, which is indicative of both and the analyzing from Gemini there. The Python's running, which is great, and we can see that it's analyzing with Gemini, so that's cool. So an excellent state with all S3 buckets encrypted, mitigating immediate data exposure risks. So that's Gemini responding, so we know we're good. So there's a few issues that can pop up here. There's the most obvious one, at least if you're on Windows, is the Google API key not being set. That can definitely happen on Mac, but more common. It's a more common Windows issue than this. This isn't a Windows issue. And there's also, a possibility you configured something incorrectly, which is completely fine. It's very easy. It's relatively, the step at least is relatively complex. So good job if you got this far. But yeah, there's a Google API key not set tab. So if you run into issues there, there's this is really a Linux or Unix issue, which is Mac and Linux. So you could rebuild with these if you run into that. If you don't, that's great, but you very well might. And if you've got a different error, you can go to the community, rebuild the package, use the ask feature here in chat to send off, or to help you out. You can send off a message there. Cool, but we're all good. Alan worked, so I'll be heading down this IC S3 scan results with AI analysis tab. So in the log output section, you'll see your scanner action. So if we go to the log at the bottom here, so start requested ID, the scan number, scanning S3 buckets for encryption. We found 4 buckets in AWS, at least in my account. It'll be different for yours likely. And these are all encrypted, so we're good to go. Then it's scanning them, and that's when it does this log output up here. And it's scan complete, so none need encryption. And there's some other stuff here, which is just extra bits. So duration there. So for example, if we had a 3-second here, it wouldn't be enough time to do the Gemini analysis. So that's why we updated this. So in the response at the top, which is from Gemini, you can see the AI analysis. Sorry, that's the bottom. The AI analysis here. I think we can look at there you go. Your scan shows excellent state with always 3 buckets encrypted. So we're good. You can see that. Makes plenty of sense. We can also see other bits throughout here. There's the name of stuff. The next work bucket, I think, or bucket. Let me just search for the next work portfolio assets. What I was looking for. Cool. So we can see our stuff configured in there, which is great. Nice. Cool. So this is sort of an overview diagram of what we've achieved so far, and that's a manual test trigger from us causing the Lambda function here to send something to the CloudWatch logs, and then return a security recommendation based on Gemini's response, and then this is fetching it from the AWS S3 buckets here. Perfect. Your AI-powered Lambda function is successfully scanning S3 buckets and providing intelligent security recommendations. Step 3 is complete. Good job. That's a bit tricky to do this bit here to get Gemini to talk through a Lambda function. So good job if you've achieved that. And if you're just troubleshooting, that's good too. So I'll just take a screenshot of this. I tested my Lambda function by running the test feature on AWS console. I tested with a manual invoke, which is manual trigger. The AI explained, let me just quote the AI exactly, what Gemini said. This shows me that the scanner successfully looked through all 4 of my S3 buckets and determined that there was no encryption required. Cool. Now, so that's the main bit of the project finished, which is super cool. I think this is such a great project to go through and to do for security and understanding how AI can be used in that space. So yeah, super stoked that we've got this far, and good job of your following along with us. We can actually look at our documentation here for a second and see how far we've come so far, which is really cool. We'll touch on this in the end as well. Alright, but we're going to head into the secret mission. You're welcome to follow along as well. Encouraged to follow along, in fact. So we're going to be scheduling daily security scans. So far, you've built a Lambda function that scans S3 buckets for security issues, but it only runs when you manually test it. Professional security teams need continuous monitoring that runs automatically without human intervention. In the secret mission, you'll automate your scanner, use EventBridge to schedule your Lambda function to run every 12 hours, creating the same automated security monitoring pattern that enterprises like Netflix, Capital One, and Capital One use in production. So this is the sort of outline here. We've got the automated security monitoring, so it can run twice daily, every 12 hours, no manual testing required. The EventBridge, which is the automated part, which runs the Lambda function every 12 hours, triggers it, which sends logs, which obviously what we were just talking about. The Lambda function is checking encryption and getting encryption status, and checking findings and getting AI recommendations back, which get fed into the CloudWatch logs. Cool. So in the secret mission, get ready to create an EventBridge rule with scheduled automation, configure the schedule to run every 12 hours, and to set Lambda as the target of this trigger, and then review and create the rule. What are we doing in this step? I'm scheduling Lambda to run automatically with EventBridge by setting it as the target event, or the target service. This will allow the testing of my S3 buckets every 12 hours automatically. Testing is including AI summary of my S3 buckets every 12 hours automatically. Cool. So we're going to create an EventBridge rule. Now you'll create or set up a schedule that triggers your Lambda function automatically every 12 hours in the AWS console. So we'll head back out of the Lambda function to the AWS console here. We're going to search for EventBridge and hover over and click Rules. I'm going to click Create Rule here. And then we're going to click Scheduled Rule Builder. So why use the Scheduled Rule Builder? EventBridge has two interfaces, one for event-based rules triggered by AWS events like EC2 started, or you got a log you don't want, or maybe you do want, and one for scheduled triggers, so triggered by time, every 12 hours, every 5 minutes, whatever you want to set it up for. The Scheduled Rule Builder is simpler for time-based automation, so we'll be using that. So we're going to define rule details, so we'll give it a rule name of daily S3 security scan, and then a description of daily automated S3 encryption scan. Cool, we'll just click next. Zoom in a little bit so you can see. Cool, so we'll select now a schedule that runs at a regular rate, such as every 10 minutes here, because that's what we're going for, and we'll set 12 hours here in the configuration, and then we'll click next. Why every 12 hours? Really, this is just an example, but this runs your scanner twice a day, e.g. at 9 a.m. and 9 p.m. So you can change it to 24 hours for once daily scans, or just adjust the number to match monitoring needs. This rate-based schedule is simpler than cron expressions for regular intervals. We can use the ask feature, the definitions feature here for what a cron expression is. A cron expression, standardized way of defining schedules for automated tasks, like running a script or commands on a recurring basis. They use a sequence of 5 or 6 fields representing minutes, hour, day, or month, separated by commas, day of the week, and optionally a year to specify when a task should be executed. But we're all good. Cool, so now we're going to select a target. And if we enter Lambda here, because we're executing a Lambda function, we can select the one we just made. So our one was called S3 security scanner. So we can click into the function, the specific function in this target account, or target in this account, sorry, to do there. I'm going to keep on create a new role for the specific resource. You can leave this as anything you want. You can name it something new if you want to. And you can add tags if you want to, but we won't be in this case. Cool, almost done. Now you'll review your configuration and create this rule. So we'll scroll down and review your rule configuration. This all looks right to me. We've got a rule name, description, event bus is automatic every 12 hours, and we're calling this Lambda function. Good to go. Cool, so this is again, what we looked at before, but we've just designed this EventBridge part on the left-hand side. So what we'll do is we will just screenshot this. We'll paste that into there. How do you configure EventBridge scheduling? I configured EventBridge by setting up the Lambda function I just designed to run every 12 hours. The schedule runs at a trigger of the specified timer being up. Specified timer running or completing maybe. Runs at a trigger. The schedule runs at a trigger of the specified timer completing. You could say this, the schedule runs at a trigger, runs the target at a trigger of the specified time completing. This automates security monitoring by adding, or I say removing the need to get information or to manually run this Lambda function each time you want to check your S3 bucket encryption. Cool. Cool. So now we're going to view automated scan results in CloudWatch logs. When EventBridge triggers your Lambda function automatically, the results go to CloudWatch logs. Let's see how to view them. What is CloudWatch? What is CloudWatch logs? CloudWatch is AWS's monitoring service that collects logs and metrics from your resources. CloudWatch logs specifically store log outputs from Lambda functions so you can debug and monitor execution. Every Lambda function automatically sends its logs, print statements, or errors to CloudWatch. So in the AWS console, let's search for CloudWatch. Hover over CloudWatch. We can go to Services. We should see a Services dashboard here. Cool, and in the Services sidebar, under Logs, you can click Log Management. Under here, Log Management. In the search bar, we can type S3 Security Scanner. It's the only thing here, but in case you've got more, we can select that. We can click on the top Log group. What is a log group? A log group is a container that organizes logs from the same source. Lambda automatically creates one for each function with the naming pattern AWS Lambda function name being the one where S3 security scanner function we're using. Cool. And then you'll see the most recent log stream at the top of the list. We can click onto this. We can see this is effectively what our the output of what we're doing is. So we can see the start request ID, scanning buckets, found for buckets, encrypted, analyzing findings of Gemini, scan complete. So yeah, that's effectively, this is where you would go to go and understand what's going on here. Yeah, so this is really great for understanding that. And if you want to see more logs appear live instead of waiting 12 hours for more, you can either run them manually or with that same invoke command we showed you before in the test section of the Lambda function, or you could go to your EventBridge rules and find that and update the 12 hours to 1 minute. Could take a couple minutes to refresh, but you'll see new log streams appear as EventBridge triggers in your Lambda function every minute. Change it back to 12 hours. You don't really want a bunch of logs to come through. It can be poor for billing performance. You might get billed more than you expect. So how does the automated security scanner work in production? So the event triggers Lambda functions every 12 hours, where the target event is the S3 scanner Lambda function. Lambda scans all S3 buckets using the Python code. The results appear in CloudWatch logs. Which are great for monitoring performance and say how many buckets you scanned. Were there any non-encrypted buckets? In production, teams use this to understand, we'll say automate S3 bucket detection say encryption detection. So how does the automated security scanner work in production? EventBridge triggers a Lambda function every 12 hours where the target event is S3 scanner Lambda function, or is the S3 scanner Lambda function. Lambda scans all S3 buckets using the Python code. That's about right. These results appear in the CloudWatch logs, which are great for monitoring performance. So it could be how many buckets you scanned, were any of them not encrypted. In production, teams use this to automate S3 bucket encryption detection. Unencryption detection. Automate detecting S3 buckets being unencrypted. Cool. So how it works in production. Now your security scanner runs automatically every 12 hours, twice daily. Lambda scans all S3 buckets for encryption. Lambda sends security findings to Gemini AI for analysis. Lambda returns results. You can see them in the CloudWatch logs, just these here. where did the results go? When EventBridge triggers a Lambda function automatically, you won't see results in the Lambda test console. Instead, Lambda logs, everything goes to the CloudWatch logs. You can view them, view the security analysis by going to CloudWatch log groups and into this this Lambda function and checking the latest log streams. In production, teams typically add SNS email notifications or Slack integrations, so results are sent directly to their security teams rather than just living in logs. What's next? You've built the foundation of autonomous security monitoring. Enterprise security teams extend this by, like we were just speaking about, adding SNS email alerts, or maybe to Slack or Discord or anything like that. For notifications, scanning, if you could scan additional AWS services, RDS, EBS volumes for encryption, or adding auto remutation that enables encryption automatically. The scheduling pattern you built is just the core, everything else builds on top of it. So I can't stress that enough. This is really like the start, because you can do a lot more with automating, especially around using Gemini with Lambda functions. So yeah, that's this project. We're going to clean up some stuff, or not everything here, but yeah, I really hope you guys enjoyed. If you followed along, I definitely recommend this project. I think it's super cool. A super good way to sort of expand and understand a little bit more about how you can use Lambda functions in AWS around S3, as well as using Gemini or an LLM to analyze that for you and help you out. Cool. So I'll just keep this running, but you can definitely go through and delete stuff if you want to. That's just in the delete everything tab. So what were the key tools and concepts you learned in this project? The key tools I used were, I'd say, Amazon S3, I'd say Lambda functions, and Python, or you could say EventBridge and Python. The main concepts I learned were, I'd say, automating encryption using Python scripts, automating S3 bucket encryption using Python scripts, and automating and scheduling the encryption checking using EventBridge. Cool. How long did this take you to complete the project? About 1.5 hours, I think. 1 hour and 20 minutes. 0.5 hours. The most challenging part was, I'd say, getting Gemini AI to talk to the Lambda function. Providing a sensible code summary. Cool. Thanks for doing this project. I did this project because I wanted to learn about how I can use LLMs to improve S3 encryption, S3 bucket, Amazon S3 bucket encryption for or automatically, maybe encryption by to improve my Amazon S3 bucket encryption, and do so automatically. Cool, that's a wrap. You did it. Good job. You've built an AI-powered AWS security scanner with automated scheduling. So this is an automated security monitoring system, like we just spoke about. This is the one higher up at the start of the secret mission. I won't go over it again, but Lambda function, getting stuff from S3 buckets and using Gemini AI to summarize those findings. And the EventBridge is used to time that, twice a day, 12 hours as we set it up, but you can change that. So what you learned: AWS Lambda serverless deployment and configuration, Gemini AI integration for security analysis, Amazon S3 encryption scanning with Boto 3, IAM roles and permissions for Lambda, EventBridge scheduled automation, security secret mission, we just did, setting every 12 hours, CloudWatch logs for monitoring automated executions. We'll just do the quiz. Which Python library utilized within the Lambda function to interact with S3 services? So we had Boto 3 for that. What is the primary role of Gemini AI in the S3 security scanner project? To transform raw security findings into actionable security recommendations. Sounds right to me. How is Gemini API key securely provided to the AWS Lambda function in this project? It's not stored in requirements. It's not configured as it is configured as an environment variable. It's not hard coded, and it isn't passed as a argument. Cool. So to allow Lambda functions to retrieve the encryption configuration of S3 buckets, which specific IAM action must be included in its policy? Okay, this is a bit tricky. To allow the Lambda function to retrieve the encryption configuration of S3 buckets, which specific IAM action must be included in its policy? S3 put object, list all buckets. It's one of these two. I'll have a look. If we open up cursor here, I'm going to say get encryption configuration. Cool, so we'll select this. Nice. When deploying a Python Lambda function from Mac OS, what is the common reason for encountering the import name GYGRPC? Python packages installed on Mac OS compatible binaries instead of Linux compatible ones. Lambda function timeout is too short. IAM lacks permission. Is this one? What is the main purpose of the requirements.txt file in the context deploying the Lambda function? To list all external libraries needs to install. Cool. Okay. All good. Thanks you guys so much if you follow along or just watching. I think this is an amazing project. Definitely recommend it. I'll quickly check out my documentation here. We can look here. You can change themes if you want to. Yeah, super great project. Definitely recommend checking it out. Great way to enter into the AI security space. You're using AI in security. All right, ciao for now.